In this section, we're going to look at one way to solve a quadratic equation. In order to solve a quadratic equation, the first thing you must look for is the quadratic equation must be equal to 0. Since in this case it is, one way we can do it is by graphing, and our equation's already written in vertex form, so it should be a very easy equation to graph. The first thing we need to do is look for where the vertex is going to be. Our x value here is 2. So we're going to go 2 in the positive direction, and our y value is going to be -1. Since there is no number in front of our squared term, we're just going to follow the regular pattern of squares and go over 1 up 1, over 2 up 4, and over 3 up 9. We're going to do that going the other way, over 1 up 1, over 2 up 4, and over 3 up 9, and draw our graph. So there's our graph of our equation. Now because we are looking for where it is equal to 0, all we have to look for is where on the graph is the y value equal to 0. And in this case it's equal to 0 right here and right here. So really when you're finding the solutions of a quadratic equation graphically, you are looking for the x-intercepts. Now this equation has two x-intercepts. It has an x-intercept at 1. So one of our solutions is x equals 1. It also has an x-intercept at 3. So the second solution is x equals 3. We could check this in our equation. If we go 1 minus 2 squared minus 1, we do get 0. 1 minus 2 is -1. -1 squared is 1. 1 minus 1 is 0. We could also check the 3. 3 minus 2 squared is going to be 1. 1 squared is 1 minus 1 is equal to 0. So we've just proved that our solutions are in fact x equals 1 and x equals 3. Depending on where your graph is, there are three possibilities for solving quadratic equations. The first possibility is that there are no solutions to the equation. And what this would look like is your parabola would go down, but it would not get to the x-axis before it would start to move back up. So if it never crosses the x-axis, there is no location on the graph where our y is equal to 0. So as a result, there are no solutions here. One solution would be if your parabola comes up to the x-axis, just touches the x-axis, and then goes back down. So in this case, the only x-intercept is the vertex. The only place where y is equal to 0 is that one point where the graph turns around. Two solutions is if the graph goes through the x-axis in two places. So in this case, you'd have a solution at this point here, and you'd have a solution at this point here. You could see these called solutions, but you could also see them called roots or zeros. Solutions, roots, and zeros all mean the same thing, and they all indicate where the graph is crossing through the x-axis. So the other thing we could point out here is all of these are equal to the x-intercepts. And that's how you solve an equation graphically. As long as it's equal to 0, you could graph your equation, and then you're just looking for the location where the graph crosses through the x-axis.